Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences Bioscience Talks, which is a forum for integrating the life sciences. For today's episode, we're joined by Peter Edmunds, who's a professor of biology at California State University, Northridge, where he's worked for over 30 years. He was here to discuss his recent article in Bioscience's new Perspective and Insight category. It's entitled, Why Keep Monitoring Coral Reefs? The article describes a now 38-year study of coral reefs in the U.S. Virgin Islands and highlights the value of long-term ecological monitoring. But I'll let him tell you the rest, so let's go straight to the interview. Thank you very much for joining me today.
My pleasure. I'm super excited to be here.
I was hoping that just to get us started, you could take us back to 1987, when this long-term monitoring actually began. What drew you to the area? What excited your interest in these reefs? What was the motivating factor there?
Well, that is a little bit of the $64 million question. And I'd like to pretend that there was a strategic plan and I'd searched the Caribbean and the world for the best venue to do this work. And that's really not what happened. I had just finished my PhD after 2 years of field work in Jamaica. I had returned to Scotland and I had graduated. I had a fresh PhD in my pocket with wet ink, and I was desperate not to spend a winter in Scotland. And the first job I was offered was to teach marine biology for the School for Field Studies in a remote swamp in the Virgin Islands. And I turned up in January of 1987 to do just that, to learn how to teach and to pretend to be a professor and start my career. And as that year unfolded, then the first Caribbean bleaching started later in that year. And we found ourselves diving on reefs with young students, and there was just epic areas of whiteness on the reef, like white trash bags strewn across the floor. And I thought, well, my goodness, I need to do something about this. I'm meant to be a biologist. And I started photographing the reefs. And after 38 years, I've never really looked back.
And where are these reefs specifically? You know, what kind of area is it in? Is it in deep water? Is it near shore, offshore, far?
These are wonderful reefs in the United States, in the Virgin Islands National Park on the south shore of St. John. And certainly part of what attracted me to studying them is that they are wonderfully easy to get to. You just put out a little boat from the shore and you're there in 3 minutes. They're fringing reef communities. They're maybe 50 meters, 100 meters from the shore, and the deepest one is in water that is about 15 meters in depth. So they're easy to get to, they're easy to work at, they're easy to come home from, and they're just a wonderfully benign, easy environment to study. And as I like to tell my young students, it's somewhere where you can smell the underwater roses. You can swim around, you can do the job of science that you are there to do, and you can think, well, my goodness, what cool stuff is going on? Let's poke around under this rock and let's look at this sea fan and think about the biology.
That's interesting. So it sounds highly accessible and, a good, exciting place to, do some research and also some learning and appreciation.
It is. It's a wonderful juxtaposition of once you're in the water, it's wonderfully easy to get there. But it has always been a remote corner of the United States and requires four-wheel drive to go down this epic road filled with potholes and sort of 30, 40 centimeter deep puddles. And it's jungle. There's trees, there's bushes, there's bugs, there's all kinds of crazy jungle sounds. And you really feel like you're at the end of the planet when you arrive at the dock to start your work. So that part of it has always been challenging. And I remember when I first started working there, Jurassic Park had just come out, and it felt like I was in Jurassic Park, and a big T-Rex would step out from behind the trees and chase me into the water. But once you're there, the coral reef biology is wonderfully easy.
And what were the reefs like at that time when you first began the study? You mentioned the bleaching event. Do we know what caused it?
Well, the bleaching event was really one of the first harbingers of global rising seawater temperature. And I don't think anybody realized that at the time, or at least they were slow to realize that at the time. And remarkably, in the mid 1980s, it seems that hardly anybody in the Caribbean was routinely walking down to the dock with a thermometer and putting a thermometer in the water and measuring the seawater temperature. And I remember going to conferences and people were like, well, who is measuring seawater temperature and who is doing this? And very few people were. So people were very slow to tumble to what was actually going on. And at that time, the reefs I don't want to say they were wonderful then and they're not wonderful now. They're wonderful now, but they were more wonderful back
Sure.
then. There was a lot more coral, there was a lot more fishes, there's a lot more topographic complexity, up and downiness, if you like, on the reef. And at some level, they just looked cleaner. There just wasn't sort of fuzzy algae. There wasn't so much sedimentation. And now when I swim over the reef, I want to swim around with a big old vacuum cleaner. I want to suck all that stuff off the reef and reveal the cleanness that was there in the 1980s.
And, the reefs have obviously changed quite a bit over time, and we'll talk more about that in just a moment. But in those initial days of the study, did you have the sense that you were looking at a degraded ecosystem or a challenged ecosystem or a changed one, or did it seem relatively original, as it were?
I was so young and so naive back then. I had done my PhD. I had had my blinkers on in Jamaica. I was working on coral physiology, and my entire life was putting small corals in boxes and measuring their oxygen uptake and their metabolism. And I turned up in the Virgin Islands, and I was broadly clueless to the big picture of what was really going on. I didn't really sort of appreciate the ecology so much as I do now, and it was much different, I think. And it took me a long time to really understand what I was looking at and what was happening and why it was important. And I think that's part of the wonderful story that I try to describe in the article. It's been a journey, and the story evolves and changes with that journey, and it becomes richer and better.
And, what was the means by which you sort of gained that knowledge? Let's talk a little bit about the, experiment itself, the study. What approach did you take?
Well, I really took a page out of my own undergraduate ecology and pages out of my own early days of instruction as a marine biology professor. And, I've seen a lot of people wring their hands in angst about monitoring. Oh my goodness, how shall I start? What should I measure? Should it be a big quadrat? Should it be a small quadrat? Should it be a transect? And my words of wisdom, like, oh my goodness, it doesn't really matter. Just start. You're better off measuring something and finding out later you've done it wrong than not start measuring, because you can't go back in time. And so I started out measuring the best I could. I rolled out transects. I pounded pieces of rebar into the reef, and I just started photographing PVC squares with a camera that I managed to buy with my first paycheck. And kind of that's how the project started. And I think, as most biologists will say who've worked at field stations, it is remarkable the number of people you encounter in those field stations and how those field stations change lives and how they mold careers. And I was very lucky to work with some wonderful young biologists who were more established than I was. And I learned from them. I learned from John Whitman. I learned from Richard Aronson. I learned from Don Levitan and others about, this is how you should probably start doing this. And I started doing it. And I made mistakes. I made mistakes as fast as I could and tried to correct them, and the project evolved.
And so, just as a very general matter, you mentioned PVC squares. You would take them out and put them in the same places that you'd previously photographed, and just take a picture from a given distance.
Pretty much that's it. And environmental ecological monitoring starts with the basic principle: you need to do the same thing every single year and do it for many years. Keep it simple, keep it easy, and keep it fun. And that's what I started. And now, looking at the project, I marvel at the concept that some days I'm out there with a fancy pants photophysiology piece of equipment doing something that's cutting edge, or I'm helping colleagues collect samples for genetic analysis. But at the same time, I still have the PVC square and I still have the camera, and I'm still taking the same photographs that I took 38 years ago, because that's the objective. The backbone of the project has to be done with the same method, or else your interpretation of how the environment has changed is like, well, maybe it changed because you changed your methodology. And of course, you don't want that to happen.
Looking back on it now, is there anything with that methodology that you would have done differently, in 1987 as you were kind of initiating the process?
Well, if I could go back in time, I would give myself a digital camera decades before digital cameras became available. And, again, funnily enough, you try and tell the youngsters that these days, they just don't believe you. But the notion of working with a camera that had this quaint concept of a roll of Kodachrome film, and it has 36 photographs on it, and the reason your sample size is n equals 36 is because, well, that's how many pictures were in the camera. Yeah, I think if I could go back, it would be I would give myself a digital camera to start earlier, because I never really knew until I flew home whether I had any pictures on that roll of film at all. And that was always super stressful. And I think sort of just having an inkling that maybe I would still be doing this in my 60s, that would have been really helpful as well. Thinking that it's a marathon, it's not a sprint. And these are the things you don't think of when you start the projects.
No, and what are the benefits of the digital camera? Is it just the immediacy of it, or is there, do you get better clarity as well?
Well, now you can get better clarity. When I first started with my first Nikon digital camera, I think I had 3.3 megapixels, and it really wasn't very good in terms of resolution. Now it's wonderful. But I think the key issue is the immediacy. You go out there, you can do your dive, and you get your images. You can look at it on the computer, and that evening, like, well, this worked, or, oh my goodness, these pictures are terrible. I need to do them again tomorrow. And so you got that principle, and at the back of your mind, this project marches ahead on photographs. So if you screw this part up, the whole project is going down in flames. And back in the day of Kodachrome, you never really knew. You took your little Kodachrome bag of, you'd have your bag of 40 rolls of Kodachrome 64, and you'd go through the airport and you'd pass them around the X-ray machine because, oh my goodness, you don't want those things fogged. And you'd pop them in the freezer and hope they would be good in the field. And you'd take the photographs and you hope you didn't mess up the exposure. And then maybe 2 weeks later, they'd come back from the film company after the expedition is done, and you just hoped and prayed you had the quality of images necessary to have that year's sampling in the bag. And to avoid that now is just wonderful.
That would have been nerve-wracking, I imagine, and I'm guessing you were very much at the mercy of those who would be developing your film remotely after you're having mailed it away.
Yes, I mean you are giving up a huge element of control to random processes, whether it's somebody at the X-ray screening at the airport, or whether it's somebody who's receiving your film at the chemists or the company that's developing it, or whether it's the postal service that's delivering it. You just kiss goodbye and you hope that 2 weeks later the source of data comes home to you.
That does sound very challenging. I'm wondering now, since we've talked a little bit about the process, about the types of changes that you've seen over the years. What does this type of long-term monitoring enable that you wouldn't get with a more of a point in time look at a reef?
As I like to say to some of the folks I talk to who make fun of me, it's where the rubber meets the road in terms of understanding how the environment is changing. And yes, if I had photographs in 1987 and I had photographs in 2024, you could reach some of the same conclusions. My goodness, this system has changed and a lot of stuff has died. But without the observations in between, you have very little idea of what caused that. Was it one catastrophic event? Was it a series of small events? Was it some kind of cyclical phenomenon? Exactly when did these things start to go south? And that's what you're able to do. And I think in contrast to the notion that, oh my goodness, the world has deteriorated and it's all because of climate change, or it's all because of bleaching, or it's all because of hurricanes. It's like, it's so much more complex than that. And understanding that complexity is key to understanding where it is that we're likely to go. And simply having one point at the start and 1 point 37 years later and drawing a line through those points and projecting into the future, massively inadequate. And then on top of that, you realize that, not everybody's on board with the old climate change story, and not everybody's on board with the world is changing around us. And I've long thought of science. It's like the most melodramatic courtroom case, and you're trying to show in your legal case this person is guilty. They did the deed. They picked up the tool and they murdered a person, and there's very well paid attorneys fighting against you, and you've got to get your act together. And so I think all I really have to offer the world is the best I can do in telling the truth, and having that data in 1 year increments does the best job and in being convincing that, oh my goodness, the world has changed. Do you want me to put 20 photographs in front of you, or do you want me to put 40 years of photographs in front of you? Dude, it's changed.
Right. You can make that compelling case because you've got, this mountain of photographic data over many years that shows, changes occurring and the complexities within.
Exactly.
And what sorts of surprises have you encountered along the way? I mean, you mentioned that it's not simply a linear story of the coral species dying on the reef. It's a lot of things that happen in between. What are kind of the surprises or unexpected findings that have cropped up along the way?
Well, there are profound surprises and there are surprises. I never thought lionfish would appear in the Caribbean. Lionfish are awesome. They live in the Pacific. They're the right fish in the right place, and they're glorious. And then, oh my goodness, suddenly they appear in the Caribbean, and they're all over the reefs, and they're gobbling up the little reef fish. I never thought that would ever happen. And I never thought weird diseases would appear. I mean, I'm a biologist. Yeah, there's diseases out there. Animals get diseases, we get diseases, and sometimes you don't make it. But I never really thought that these sort of big diseases would sweep through the Caribbean. I never expected to see the beautiful pillar corals just disappear within a year because of a disease. I started my graduate career 2 years after the sea urchin diadema died off throughout the Caribbean, and the field of marine biology was just absolutely blindsided by the death of the sea urchin that virtually forever changed the Caribbean reefs. And then in 2022, I never expected to see another disease come through and wipe out the diadema, and we saw that happen as well. So some of the events are really striking. The appearance of lionfish in the Caribbean just blew my mind. But then other things are just are much more subtle, and I try to sort of portray that in the paper. When I was young and naive, and I saw Hurricane Hugo come through in the first few years of the study, like, oh my goodness, this is the most devastating thing that's ever hit the Caribbean on these reefs, and it will forever change the reefs. And the big surprise is that 37 years later, you know what? Not really. No, it killed a bunch of corals, but really the big story is the 1 or 2% that died off every single year, the proverbial death by 1,000 cuts. And you can focus on the hurricane in 1989, and yes, that killed a lot of corals, but it's far less impressive than the 1% that died every year for 30 years.
And is that 1% that died every year, is that largely a result of, as you mentioned earlier, the changing water temperatures?
I would certainly point my finger at the changing water temperature, and I've just finished analysis that was published in another journal that made that case that if when you've got 37 years of data and you've seen the same disturbances happen 2 or 3 times over that period, and you've got the data on the temperature records, you can really get into the nitty-gritty of statistically testing. Did temperature really do this, or did hurricanes do this? And certainly that's the Achilles heel of this kind of work, that you can't establish cause and effect because you're observing a natural system. But the evidence is very compelling that temperature explains a lot of what has happened on these reefs.
So how has the reefs changed over the years that you've studied? You've touched on it a little bit already, but what's different now about those habitats than it was in 1987?
Well, at a gross human level, it would be there's just less of everything. There's less fish, there's less coral, there's more sort of algae and sediment and dirt on the seafloor. And if you go down to the Virgin Islands in March and you jump off the dock, you jump in the water like, ooh, it's kind of warm. And in 1987, you jump off the dock into the water like, whoa, this is pretty darn chilly. And back in 1987, you used to get 25.5 degrees Celsius winters all the time. And now you hardly ever get that at all. You jump in the water in March, like, this is pretty warm. It's not that chilly. So there's a whole bunch of of very conspicuous things you notice as a human observer. And as a scientist, you translate that into statistical reductions in the abundance of corals, and you see many of the species far less frequently, and you see reductions in the abundance of invertebrates, and you just see these gradual changes in the community. And again, you go back to the photographs and you refresh your memories like, oh my goodness, this system has just changed epically.
And I guess now a non-science question, is that depressing? Is it frustrating or sad to, see the way that these ecosystems have changed over the years?
It's interesting that you should ask that. This year, I've given a number of talks to college groups, and I've been struck by how often I get that question from undergrads, kind of in the early 20s demographic. And I think there is a tremendous sort of concern among young adults, old adults alike, on the state of the environment. And they said to me, well, how do you stay so optimistic when everything around you seems to be dying? And I feel to some extent my job is like a reporter. I'm out there in the environment, and I'm not supposed to wring my hands in angst at what it is that I see. My job is to report what is there and to be objective. And at some level, yes, I miss some of my friends on the reef. I miss the corals. I was telling one of my colleagues, well, I go out to my study site and I swim and I swim and I swim, then I swim and I swim and I swim, and then I find a big pillar coral and I turn left at the pillar coral, and there's my site marker. And then suddenly in 2020, like, oh my goodness, that pillar coral friend, oh my goodness, is dead. And yes, that is a little sad, but there's a lot of my friends present on the reef still. They're just not so common, and you have to look harder for them. And I'm very encouraged that I find the pieces of the puzzle still there, and it makes me optimistic that we could put it together. I don't think it's helpful to fixate on what is lost and be overly depressed about it, because that won't really help anything. I think if we can be optimistic and we can tell the truth and push back on falsities everywhere, then that is the best option for ensuring their survival. And yes, there's so little coral in the Virgin Islands now, but I can still take you out there and I can show you, well, here is a pillar coral, and here is an acropora coral, and here is another kind of coral. I can find all the pieces of the puzzle, and it makes me optimistic that they may still be able to be put together.
And what would putting those pieces of the puzzle back together look like? Is there a realistic chance for meaningful recovery, if not of entire reef systems? What would success look like in that perspective?
Well, at the moment, I would take success is maintaining the species in the environment. I'm pretty happy that I can still find my friends out there. I think the notion of rebuilding the reefs is still a fairly elusive concept. And I think reef restoration is a wonderful concept. And anything that gets young adults engaged with the environment and thinking about biology is awesome. And if you've got a reef in front of your favorite beach, or in front of your favorite hotel, or in front of your favorite guest house, and you wanted to change that, yes, you could put a bunch of people in the water, you could remove the algae, you could stick corals on the bottom, and you could make that look like a wonderful garden. Whether you could propagate that over thousands of kilometers of reef, probably not. That's just not realistic. I think more will have to change to make that happen, in terms of alterations in climate change, in terms of alterations in broad human environmental interactions. But I think we can ensure corals persist, and we can do things to help them regrow in small areas. And in a very dystopian future, I would like to think that we could know enough about a coral reef that in maybe 200 or 300 years' time, somebody could come by and say, We want to build a coral reef from scratch in the middle of this ocean. Off you go. And we want to know enough to be able to do that. And I think we don't need to be able to do that because we have to do that. But I think it would be good to get to a point where we might be able to do that in the future. And we've got a lot to learn.
And you may have partly answered this next question, but one of the main points of the article, and in fact it derived from the title, is the idea of why we should continue monitoring these reefs. I was hoping you could just tell us a little bit, why the article was titled that, and give us a little bit of an idea of the case that you make within.
Well, I think I have the best job in the world. I travel around the world. I work with fantastically motivated people. I work on one of the most beautiful ecosystems in the world. And as I travel, I like to talk to people. And I was talking to a colleague, and they said to me, well, we don't really need to study reefs anymore. We know they're dead, and we know why they died. So we don't really need more science. And I was really taken aback by that and was shocked. And so that's what motivated me to write this paper. I'd been mulling it over for quite a number of years, and that was the catalyst that got me to write it, to address this issue. Why should we monitor reefs in the sense that some people think they're already gone? What's the point? And I just wanted to push back on that as boldly as I can. Like, oh my goodness, now we need to monitor reefs and study them even more. This is not the time to stop. And I think to some extent, the spoiler interpretation is, well, we know how they function and we know that they've died. We know why they have been killed. That's not really true. We know how they died in the 1980s. We know how they died in the 1990s. We know these things, but we're playing by a different rule book now. And the old rules don't necessarily apply to the new sets of conditions with warmer seawater and more frequent storms. And I think that's a critical reason why we need to keep doing this. And if there is going to be any realistic hope of pushing back with restoration and changing environment, that will only happen if we really know what is still there and how it's changing.
And so we could wind up, if we weren't to do this sort of research, in a situation in which we might want to restore an ecosystem, but we don't have ample evidence on how it got into its current state.
Exactly. And I also buy into the notion that if we don't talk about something, if we don't keep airing it, then people will forget. And I think if people forget, again, it's like, oh my goodness, we're doomed. And I love my science, and I love what it is I do. And some of the things that are really important to me are getting young adults into the environment. I'll fight tooth and nail to get the field trip supported, to get people in the field, to get young adults away from their phones and their tablets and get them in the water to see the environment. And as much as I can, I'll keep talking about the environment to keep people aware of the fact there are problems out there and there are awesome communities out there, and you need to go out there and look, and you need to witness it yourself, come back and be convinced and do your best to fight against it. If we don't talk about it, again, that will be a mega part of the problem.
And do you know off the top of your head, how many students you've had out there on the reef?
Funnily enough, I just tallied that up. I work in an institution where our terminal degree is the master's degree, which it has many benefits and it has some limitations. But this year, I reached a total of 46 master students over the lifetime of my career, all of whom have been channeled through coral reef environments. And then each year, as much as I can, I bring additional students and additional colleagues. And with the programs I've taught, it's got to be well over 200 people I've been able to get to the field. And one of the most rewarding things happened to me a few years ago was I got an email from a gentleman in New York, and he wrote to me out of the blue and said, well, you won't remember me, but I was one of your students in 1987 in the Virgin Islands, and I'm now a highly successful banker in New York. And one of my clients has come to me and has asked me about environmentally appropriate investment options. I thought, well, I'll call up Peter Edmunds and ask him what his thoughts are. And it was just such a rewarding moment. Like, oh my goodness, this is what it's all about. I preach about the environment and I do my best. And obviously the people I interact with aren't going to necessarily become biologists, but when they're titans of corporate America and in charge of businesses and something arrives on their desk, they could do the right thing or they could do the wrong thing for the environment. It's wonderfully rewarding thinking, Yeah, they remembered that weird British guy going off on his tirade about the environment. We'll try and do the right thing.
That's exciting. Those ripple effects can be very very long lived. I'm guessing now to sort of close out the conversation. Maybe what's next for this research? Will the is the monitoring to continue under the same sort of program that you've established 37 years ago?
Well, I certainly hope so. I mean, at this point in my life, I've realized that I am not immortal. I am currently working on another submission to the National Science Foundation to get me another 5 years of support to continue this work. But I'm also trying to bake into that initiative to make the project sort of kind of immortal in the sense that I buy into the notion of open access of data and public domain data, public domain access. And so I'm baking that into the project and trying to provide means by which the methods can be inherited into other programs. But I sure hope this will continue. And I think that, that's one of my last proposals. I was criticized. Well, my goodness, Edmunds is getting a bit old. He doesn't seem to have a succession plan. What's up with that? And I pushed back against that and said, well, I don't have a succession plan, but I worked pretty darn hard to make these data available. You can go online and you can download 13,900 photographs from CSUN Box and you can analyze them yourself. They're out there. And so I'm providing a way for the project to live in perpetuity. And I think in due course, people will come along and think, oh my goodness, well, Edmunds surveyed these sites 30 years ago. Let's go back and do it again. And they'll be able to find the references, the GPS points, and do it again. But I'm committed to this notion. This work has to go on. I'm also lucky enough to be involved in the National Science Foundation long-term ecological research project. And so as a PI, I also advanced that agenda in the South Pacific. And it's the same kind of story. Our lives are sadly short, but these ecological questions play out over decades and centuries.
That's very exciting, and I think we'll all hope that this research continues for as long as it possibly can. And thank you very much for sharing the story with both our readers and now with our listeners. Thank you very much for joining me.
My pleasure. Thank you very much for hearing me out. It's been a wonderful experience.
And that concludes this episode of Bioscience Talks. Just a reminder, the journal Bioscience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.